Okay, good afternoon, and thank you for coming to my talk. When I was making a submission to Android Summit, I had a bunch of ideas around Gradle, Firebase Test Lab, Android testing. So I just mixed all of them and have this talk today called Graphite. Talks a little about Gradle, a little about cloud testing, and how you can use that for Android testing, unit as well as instrumentation testing. So let's start with Gradle, actually. So the way you run Gradle tasks are using the Gradle W command. And what the Gradle W command actually is actually a small script file which downloads the latest version of Gradle, or in the case of Android, the one specified in the Gradle wrapper properties, and uses that to run the different tasks. When you run Gradle W the first time, you'll get some helpful messages like this. And the one that you may be interested in is Gradle W tasks. It will list all the tasks that are packaged as a part of the project. In a regular Android Java project, when you do Gradle tasks, you'll see something like this. However, when you do it for an Android project, you'll see something a lot more. And that's because of the Android plugin for Gradle. What the Android plugin for Gradle does is it bundles in a bunch of additional tasks, like the Android tasks, which will sign the APK, the build tasks that will build the APK, the install tasks that will install on the device or the emulator, and the verification tasks. These are the testing tasks. These are the tasks that I'll be covering today, talking more about. Okay, so let me start with unit tests. As you may know, all the unit tests for Android are placed in the test folder. The Gradle command to run all unit tests is just test. You hit test, and it runs all the unit tests across all the modules. If you're interested in running tests for a particular flavor, such as debug, release, you need to specify that. So test, name of the flavor, unit test. You can also run a particular method, a particular test, by specifying dash tests, the package name and the name of the method. And it also supports wildcards. So you don't remember the name of the test, okay, or you want to run all the tests that have this in the title, it'll do that. Okay, instrumentation tests, as mentioned before, the ones that run on devices. These are placed in the Android test folder. And the way to run them is just Gradle W connected Android test, or cat. If you just write CAT, C lowercase at capital, it'll run the instrumentation tests. You need an emulator running or a device connected at that point. Again, you can specify a specific instrumentation test that you want to run by specifying the package name and the class name using this command. You have to pass in the class property to the Gradle task. There is, however, one issue here. If you use the magic combination of test coverage enabled true, test orchestration enabled 1.02, and Gradle plugin less than 3.2, it might give you a message saying empty test suite. This is actually filed with Google. There's a bug open for this. So don't use this magic combination, or use orchestration 1.0.1. Me personally, I think this worked for me. So if you encounter the issue empty test suite, just make sure you upgrade to the latest beta version. This does require 4.9 Gradle version. Filtering tests. So you can annotate tests, and there is a Google blog post on that. Typically, you want to annotate tests like small tests, so your unit tests that run less than 100 milliseconds, so you'll probably annotate them as small tests. Medium tests, maybe every time you check in code, you want to run them. And the large ones that you run probably once a day. So there is a Gradle command to run the tests based on the size also. So just pass in the property for size for connected Android test, and it will run them. And test. Okay. So within the root build Gradle file, there is a test options section which helps you provide some properties for the different test options, such as you can specify the report directory or the result directory. Typically, they're placed in the build folder, but you can probably put them somewhere else if you want, so that all the report and results come in one place and you can sort of aggregate them, use for aggregation. You can specify the default test build type to something else. If it's debugged by default, but if you have something else like internal or release, something else, you won't do that, you could do that. Within the test options block, there is a unit tests block. And what that helps you is, provides you two options there. One is include Android resources. If you set this to true, before you run your unit tests, Android Studio will actually merge all the assets and all that you may require for your unit tests. The second node is return default values true. If you use any unmocked method from the Android jar, it'll throw an exception. And if you don't want it to throw an exception, maybe return 0 and 1 during your unit tests. You want to set this to true, so it'll return 0 or 1 so that your test goes on instead of throwing an exception. Okay, so the rest of the talk, I'll be talking about code coverage. This is opposed to device coverage or test. Code coverage reports and how to generate them. So code coverage report, just a quick primer, is the number of lines of code that are covered by your tests. So to start off, what you want to do is you want to set up test coverage enabled true within the Gradle file. Once you do that, you just need to run this command, create debug coverage report. This will generate the coverage report for just the instrumentation tests, though. There is some issue with unit tests. If you don't get the coverage report, you probably want to put this apply plugin JCoco. JCoco stands for Java Code Coverage. And this will create the coverage report within this folder in the build directory. This is just the raw coverage report. So you have the instrumentation test coverage report, the raw unit test coverage report, and you want to merge them together. So you'll have to create, write a custom Gradle task for that. So let's talk about Gradle tasks. So this is what typical Gradle task looks like. You may have seen some of them. You have the task name. An important point here is type. So Gradle comes packaged with some types that you can leverage for writing Gradle tasks. See, for example, you want to write a simple Gradle task to perform a copy from one location to another location. There's actually a type for that called copy, which gives you two variables, from and to. So from and to, you can specify, and then do the copy operation. If you were to write this task without from and to, you'll get the error, DSL method not found. Okay. So when you're writing this Gradle task, you'll probably have the name there, the type that I mentioned, something pre-built that you want to use, description that's probably meaningful enough so when people hover over your task, they know what it does. This is an important part. Let's say your task actually needs another task to run. Most likely, the code coverage report will need the tests to run. So you want to specify this here. Depends on test debug unit test task. This is optional. This will just help you understand, OK, these are the tasks that you created. So you can say personal. In the beginning, I mentioned, remember, Android tasks, build tasks. Those are all specified using group. So you can probably put your task in verification. There'll be test tasks. During runtime, if you want to pass in some parameter, some value, this is the way to do it. You write task name, -p property name, and the value. And within the task, you want to check for that property, if it's present, and then use it. OK, so we will go back to the raw unit test coverage report and the instrumentation test reports and try to combine them together. So like I mentioned, there is a type for this. It's called a JCoco report. So you want to probably leverage that. Obviously, depends on test debug unit test and create debug coverage report. So you have the reports, raw reports available for you. So the first step in creating the unified report is to specify a file filter. You probably want the code coverage on the code that you have written, not on the generated code, the R class, and all those things. So you want to specify what you want to exclude from the coverage report. That's the file filter. The next part is the coverage source directories. This is the actual code that you have written, Java, Kotlin. Specify the location for that. And the class files. Okay, so this is where you'll apply the file filter. Your coverage directory will be converted to the class files and include the generated files. So you want to remove those generated files by applying the file filter. An important point to note here is the Kotlin classes, if you're using Kotlin. The Kotlin classes, when converted to the class files, are stored in a different location. So the second line you see there, build tmp kotlin-classes, that's you want to specify. The Java classes are stored in build, intermediate, and classes. So with that, all the type that JCoco report asks for is the source directories that you've already specified, the class directories that you've applied the file filter on, and the execution data. So the execution data is actually the raw report that you got because of running the tests. So to specify the location for these, coverage.exec for instrumentation tests, and test debug unit test.exec for unit tests. Yeah. The last step here is to specify what kind of report you're looking for. So if you're looking for just an XML report, you say XML enabled true. If you want the HTML report also, then you say HTML enabled true, and you'll get the specific report. These reports will be generated in the build directory inside the reports folder, inside JCoco. And they'll probably look something like this. So you'll have the class name, what the coverage is, and where all you lack. You can dig in deeper and see which lines are covered and which lines are not. A couple of small points here. One is roboelectric tests. There seems to be some issue with roboelectric tests. You need to specify the include no location classes as true for the JCoco node. JCoco node is not supported anymore in the unit tests block. So the workaround for that is to search for all the tasks of type test and then specify include no location classes as true for that. So in case if you're using roboelectric tests and you see your coverage is not matching it, so this might be the issue. Another point here is Kotlin data classes. You guys probably are using Kotlin data classes. So let me give you an example. Let's say you have a data class such as this, just a single line of code, and you create a coverage report. The coverage report will come out something like this. And that's because of the generated Java methods for that Kotlin data class, like equals, hash code, toString. That is, unfortunately, the default behavior for JCoco 0.8.1. However, somebody from JetBrains actually created a PR with JCoco, and the PR was approved, but it was merged in the snapshot build. So if you want to eliminate these generated methods, Java classes, you can use the snapshot build. The JCoco snapshot build is not in the central Maven repository. It's in a different repository location. So you may want to use this one. And then you have to specify the tool version as 0.8.2 snapshot. OK. Point about multi-module apps. Now, I'm pretty sure most of you must be using multi-module apps just to make use of the incremental build times. So let's say you have a multi-module app, something like typically an app module, a models module, and a networking module. If you followed the steps that I mentioned, you probably end up writing a separate task for all of them, which is probably not what you want to do, write a separate task everywhere. So what will be helpful for you here is Gradle methods. So in the root build Gradle directory, you can actually write a method and write a task in these particular specific modules. So once you write the method, you apply this method to all these modules, and then the particular task will be automatically created there instead of repeating the task everywhere. What does the Gradle method look like? A Gradle method looks something like this, where you specify the name of the method that you want to apply, what parameters you'll be passing in, like the build variant, the project. The project will then help you navigate to the specific class directories or the source directories or the coverage reports. Within that, then you can say, you know what, create a task of type, of name jcode test report, type jcode test. And then you specify all the parameters, all the source directories, all the coverage report locations there. And just apply this to a specific module within the directory. Apply this to all the modules. Combining reports. Now, Android does provide a plugin called Android Reporting. So when you do run the instrumentation tests, you can just say merge Android reports and create a combined report for all the different modules within the root build directory, of course. You can try that for the test coverage report, but that will not work. So in that case, what you want to do is you want to specify a unified reporting task again in the root build Gradle directory. So what that does is it will take use of the root project variable. The root project variable is from where you can start at the root level and navigate to all the different modules, all the different class directories or source directories or the reports, fetch them, and build your coverage source directories, class directories, and execution data. And eventually, this will be available in the root build directory. So that is the spiel about coverage reports. I'll now talk about cloud testing. So cloud testing. There's a good talk by Shavik right now. He did mention about a bunch of these. I'm going to talk about Firebase Test Lab since nobody spoke about it. Just kidding. Actually, there's been a lot of talk about it. So as Shavik mentioned, Test Lab was announced for iOS this year, and it supports a wide range of devices and emulators. Some technical aspects about Test Lab that are useful, that you might find useful, are Test Lab provides some good exit codes that can play well with your scripts. So say you have a UI test that you anticipate takes a long time, but then you want it to time out. So you can specify this timeout and then say, you know what, if it runs for more than a minute, just time it out. You will not get a failed report, you'll get a timeout code back, so you know exactly what's happening there. So that's one cool, neat thing about Firebase Test Lab. Yeah, of course, performance metrics are enabled by default. You may want to disable them if you don't want them. Okay, so this is an interesting part that you can specify the results bucket. So by default, what Firebase does is it creates a bucket where all the test lab artifacts are uploaded, like the test APK, the reports, the coverage reports. You can specify your own bucket. And what you can do is once the test is done, you can just delete everything from there. So your APK probably or a report is not hanging out there somewhere if you want. I'll talk a little more about that just a little later. So I've mentioned before, these artifacts for test lab are stored within G-Cloud bucket. And they contain not only just the reports, but also coverage reports, and then full logs, etc. So running tests. If you want to view what device options you have available on Firebase, there's a simple command for that, G-Cloud Firebase Test Android models list. This will list all the device options that are available. The important thing here is the model ID. So if you see the emulators, it's probably not visible here clearly, but the bottom line is actually the physical Nexus 5 device. That's a model name, but the model ID is Hammerhead. So you want to look for what model ID you need to use for the different devices. The model ID will be probably sometimes vastly different from the model name. So the command line, I'll just quickly go through this as Shavik already went through this. This is where it starts. It starts with Gcloud Firebase Test Android run. You want to specify the type as instrumentation. You have game loop and robo for the other options. You need to specify the location of the APK, app APK, that will be uploaded. Test APK, that will be uploaded. Device IDs, Nexus 5, so this is the emulator, since I've not written Hammerhead here. The OS version, there are some defaults here. And the last part here is environment variables. So again, I'll tie in coverage reporting here. If you want to fetch the coverage report, the tests are on the device, and the coverage reports are stored on the device. So then in your manifest, you have to enable device storage as true, and then put this line in the command line. So then the report is actually generated from, is stored in the device, picked from the device, put on Gcloud, and then you have to fetch it from Gcloud. So I'll talk about fetching here. As I mentioned, they're stored on Gcloud. If you want to access this, you'll need to install the gsutil command line interface. And after that, it's just like a simple Unix shell script. So you have gsutil and then ls, rm, anything, cp, they all just work. You have to specify the specific Google Cloud bucket location. So if you do ls this, the name of the bucket, it'll list everything in there. So how do you fetch the coverage report? So as I mentioned, you have to enable device storage in the manifest as true. When you run the command, you'll have to say directories to pull, so it'll pull everything from the SD card from the device. And then you have to just specify the location of the coverage report in the bucket and pull it. Okay, so a note here about testing UI tests that may take a lot of time. So the way I think Firebase runs is it'll take a device and then run a test and keep running the test sequentially. But what if you want to just distribute these tests across different devices? Like take your 300 unit tests, or sorry, 300 UI tests and then put a single UI test on a separate device. There is an open source tool called Flank that will help you do that. It is built by folks from Walmart Lab, essentially for scaling automated UI tests from Espresso or APM. They do provide throttling support, so if you have 300 tests, but you don't want 300 tests, you just want 100 devices, you can say, you know what, throttling at 100. Again, device config, what kind of devices you want to put there. And then once you run all these tests using Flank, Flank downloads everything into a results directory right into your root project. So you don't have to keep fetching things from the bucket or anywhere. So, yeah. So a quick demo of how Flank runs. So you have 5 tests. Let's say each test takes 20 seconds. So in the beginning, it'll run all the tests on an individual device. It will then store the test times. So what Firebase does is it charges based on per minute. So even if you run a test for 10 seconds, it will not charge you for 10 seconds, it will charge you for the whole minute. So what Flank does is it then aggregates these test times and then does it economically for you. So the next time you run it, it'll remember, you know what, test 1, 2, 3, each of them took 20 seconds, so that's 1 minute. So what I'm going to do is I'm going to run the first 3 tests on one device and then go like that forward. So basically, it uses test times to distribute the tests across devices. You can read a lot more about this at their GitHub project or their blog. So at this point, I'm sure you have questions around, wow, that is a lot of code. Do you have a sample project that exhibits all of this? And I do. So let me just see if I can share this here. So I have a GitHub repo. I'll give a link to this and just give a quick rundown on what it is doing. So this project is called Graphite, its name. It has got two modules, app and model. And what it's doing is it's actually going to create the coverage report. So if you run through this, register your app with Firebase console, create a Firebase project, register your app with Firebase console, and then specify the G-code bucket. You can run these scripts, and eventually you'll get a report here that says test coverage 100%, because I've written tests for that. So I'll just quickly walk through what it's doing and what you may want to do. So let's say you have your environment set up within Jenkins, right? When you first run the Firebase command, it'll call Firebase. It'll upload the APKs and artifacts to gcloud. Firebase will then fetch it from gcloud and then run it on the farm of devices. Once it gets the coverage reports or all the stuff, it'll again put it back into gcloud. And then you can then fetch it from gcloud into your continuous integration environment. In the meantime, parallelly, you can have your unit tests running and get information from there. You have got all the coverage reports, all the raw reports now. You can feed it to the custom Gradle task here, which will then generate the coverage report for you. And that is it. So that is my GitHub link, and please feel free to download the project. I will be around till the evening, so if you want to actually get in touch with me, if you're having any trouble, feel free to reach out to me. I'll be more than happy to help you set it up. That's my Twitter handle. You can just message me. And all the slides are available at Speaker Deck, so that is it.